Hi everyone, welcome to Future Application Summit. My name is Sandeep Alur, and at Microsoft India, I head this group called Microsoft Technology Center. We're entering an interesting phase in the industry where industrial metaverse is touted to be the next big thing in the next foreseeable future, which is about 5 to 8 years down the line. But right now, the world of IoT is exploding, the world of digital twin has arrived, and of course, eventually complementing the experience which is going to be embellished by metaverse as a design thinking. Now, of course, if you look at analysts' reports in the last, I would say, few months, it's been dominantly made clear that last 24 months has been a time where manufacturing industry, retail, healthcare, to name a few, have invested looking at short-term solutions that they're looking at. Of course, starting 2022 onwards, it's going to be long-term innovations. That means industry would go back to the drawing board, look at how they can amplify experiences considering various personas in organization, right? Of course, IoT will become omnipresent one fine day, and thanks to 5G, which is around the corner, eventually that's going to get us to a state which is called as connected system or connected ecosystem. Yeah. So for the next 45 minutes or so, we'll look at the design thinking behind how the power of IoT, digital twin, mixed reality will come together to make it very real for enterprise going forward. Now, quickly, before we get to specifics of how we'll innovate as we go along, as Microsoft, we have a platform offering, and we'll talk about what that offering is all about, and I'm going to showcase a few demos to make it very real for all of you today. Number one, yes, if you look at stage one, it is all about getting things connected, right? If you look at it, we call it as connect assets, right? Let's take a smart building. There are a ton of sensors all around. Now the question is, are they connected? So the first task is to look at asset connectivity using the power of networking and internet right there. And number two, of course, we're looking at connected environments, right? That means you connect assets for sure, but how about impact of the current systems on the environment or current assets on the environment? And eventually it's going to be connected ecosystem. Yeah, so that's future. Another perspective here, right now if you look at the transition industry is making, we're right now, it's a three-phase approach, right? We're moving from connected systems to looking at how do we look at predictive nature of business and eventually prescriptive nature of it, right? So three-phase approach, dominantly industry is a cusp where they're looking at connected systems and descriptive statistics and eventually move towards predictive statistics and eventually prescriptive. Yeah, so this is the trajectory we're seeing in the industry across, and of course, thanks to innovation under the realm of IoT digital twin, it's dominantly been democratized for every business to use at ease, and so that they can focus on taking up key industry scenarios. Now, when we speak about evolution in the industry, there's one evolution which is active right now, which is metaverse evolution, right? So that's something which, of course, there's a different topic and different session that's out there, but today's the focus is, while we're on that evolution, the first here and now element is digital twin and mixed reality, right? The focus for today would be on this first pillar. We're going to go deeper on that. Now, let's look at this. As Microsoft, our worldview for a long time has been intelligent cloud, intelligent edge. Yeah, of course, more than ever, thanks to 5G, the mobile first nature of it, right, which is the cloud complementing the edge infrastructure is only going to get better. That means if I'm using edge device with the power of 5G, I'm a lot more connected, experience will only be a lot more amplified in that sense. Now, the question is, in that context, solutions will pan across the edge and the cloud infrastructure, right? Of course, cloud complementing edge design thinking. Now, the question is, what can you do with digital twins? All of us understand that digital twin is a virtual replica of physical asset or environment. So what can you do with that? We'll just decipher that and then we'll move forward to understand the technology blocks going to complement that design thinking. Now, as I said, the basic premise or the foundation of a digital twin is to synchronize the physical environment in the virtual world, right? So that means the virtual replica that we see is a mirror image of what is happening in the physical world, and that to be in sync, right? That means information flows across from the physical world to the virtual world. Of course, if something changes the virtual world, if that is to be applied back, that has to be synced back to the digital world, physical world also, right? That's we'll look at as we go along. Number one. And number two, the question is ability for us to monitor in real time. The reason why building a digital twin is to look at overall operations in real time and having a holistic perspective of all the operations in one time, right. So, hence ability for us to monitor in real time becomes a necessity and a dire need. And once you are on the trail, having looked at data that is coming in from historical operations, the question is, can you track the past? That means it is dominantly descriptive statistics, tracking the past, and it does not end there. End of the day, it is about analysis in terms of what may happen in the future, right. Looking at historical data, can you simulate? The best part of digital twin is, yes, you are in the virtual world, and hence you will be able to simulate things as you go along, and that is where the predictive nature of the business comes in. That means you will be able to predict what may happen in the future, looking at historical data that you can analyze and then prepare for what may happen in the future. So, it is an important aspect on the trail of digital twin, because it is not about looking at what happened in the past. The question is, looking at what has happened in the past, historical data, can we predict in terms of what might be the future state of this particular environment. Now, of course, many times when you want to predict for the future, you also want to simulate what if this happens, how will the physical environment behave or operate under circumstances. So, simulation becomes a very critical component, and of course, we are talking about simulation to the extent of changing the operating procedures in the virtual world and see the impact on the physical environment. It may happen as you go along. So, of course, you test everything virtually, right. You do not apply it to the physical environment till you are sure on the outcome. Yeah? So, simulation becomes an essential component of a digital twin environment. Of course, this is where you also bring in autonomous controls, right. This again makes a point of view. Now, autonomy. So, we have done automation for a long time, and industry is at a cusp where there is a shift happening from automation to autonomy. And autonomy does not come easy, right. When it comes to autonomous systems, you are talking about no human in the loop. Automation, you may bring a human in the loop to look at and reflect on any action to be taken, but autonomous system, they are all self-healing. Actions are taken in real time depending on environmental input, right. There is no human in the loop. That is the best part, and that is where you simulate in the virtual environment and see what will be the impact if at all this happens, and how will the system behave. Yeah, and of course, interactivity. See, it does not end with we just looking at a digital twin as a virtual replica, and you can't interact with it. You interact with it as if it's a physical existence, right. That means the data that you're seeing on the digital twin is a classic manifestation of what's in the physical world, and if there's a need, you basically change parameters in the virtual world, which is applied back to the physical world as an action, right. That's where interactivity comes in. So, end of the day, the physical and the virtual coming together, of course, that's the classic manifestation of mixed reality as a technique or a framework, but in reality, need of that is to bring in a digital twin which is highly interactive in nature. That way you can actually control the physical operations. Of course, the term metaverse doesn't take a back seat. In fact, there is a metaverse stack that we announced as Microsoft. We'll just look at that as we go along. Everything we've spoken so far, from physical world to synchronizing the data between physical and virtual world and bringing interactivity. So, all of this becomes part of the metaverse stack, right. And if it's about people, places, things and processes as a metaverse design construct. Now, can metaverse capabilities come together to light up the experience? Absolutely yes, and we'll look at that. Now, this is the technology alignment to each of these capabilities, right. From if you want to replicate the sensor data in the virtual physical world onto the virtual environment, that's where IOT comes in picture, digital twin comes in the picture. Azure digital twin dominantly becomes a foundation for us to eventually move forward and build a virtual replica, which is a visualization, of course, but the behind the scenes is all Azure digital twin. Yeah. So, if you go on from there, for a very relevant evidence showcase from AB InBev, one of the largest breweries in the US. So, we look at that example in terms of how they use digital twin, but if you look at these the way technology is stacking up from Azure IoT till the Microsoft Mesh or HoloLens, right. That's the eventual classic facade for experience, but underneath, when it comes to descriptive statistics, predictive statistics, be it machine learning, Power BI visualization, all the stuff comes in beautifully together to light up this experience for a consumer. So, what we'll do now is take a look at this wonderful evidence from AB InBev to see how they use the power of digital twin to manage operations at the facility. Let's play the video.
With more than 200 breweries and 160,000 employees across the globe, Anheuser-Busch InBev is the largest brewer in the world, with an unparalleled portfolio of brands and a global presence with operations in 50 markets. AB InBev is an expert in their field, and their forward-leaning and innovative spirit is leading to new breakthroughs in brewing. Through their digital factory and supply chain of the future initiatives, in collaboration with Microsoft, AB InBev is focused on transforming both breweries and their global operations by empowering their frontline colleagues with digital solutions that enable world-class manufacturing, mobility, data automation, and business insights. It begins with the brewery coming to life with AI, Azure Digital Twins, and the Microsoft Cloud. The brewmaster is responsible for making the best quality beer. She has unprecedented visibility into the brewing process, so she can predict and monitor the complex chemical and biological fermentation parameters required to produce the highest quality product. Frontline operations can remotely monitor critical quality and traceability data from the manufacturing execution systems using the mobile brewery technology built using Azure. With built-in energy and utility management solutions, the digital brewery supports AB InBev's industry-leading sustainable development goals. After the perfect batch is ready to be bottled and shipped, AB InBev extend their digital twin solution to support the packaging line operations to ensure it's done right. These can plans are adopting Azure AI and Microsoft Project Bonsai's deep reinforcement learning to deliver line balancing optimization that detects and automatically compensates for bottlenecks in the complex can manufacturing operations. At AB InBev, their 100% uptime mindset is enabled through predictive maintenance and global support. A frontline operator can efficiently address problems through remote collaboration with a maintenance technician, ensuring no unplanned downtime of packaging equipment. The perfect beer is packaged and ready. The digital technologies of the AB InBev supply chain of the future minimizes carbon footprint while making sure the right beer gets to the right customer at the right time. This beer's journey is complete, and AB InBev and Microsoft are taking bold steps into the future.
Perfect. That is a classic evidence of how AB InBev uses the power of IoT, digital twin, and eventually mixed reality to pretty much manage the show on the ground across their manufacturing plant. Awesome. So what we'll do before moving forward is, while we get into specifics of how AB InBev went about implementing it, let's spend some time on to understand what are the building blocks of Azure Digital Twin, right? It's very simple, straightforward, because dominantly it's all democratized, but technicalities behind how do we enable a digital twin is something we should understand right away before we double click on even further deeper capabilities. Let's look at this. Imagine you have a smart factory, smart building, right? That's where you would have infused IoT sensors to track data in real time, or even otherwise for that matter. And eventually the data is being pushed or even pulled for that matter into Azure Cloud Services, right? So because end of the day, you're looking at constructing a twin, so data has to travel. The itinerary is from on-premise to the public cloud, and that's what is happening right now. Now, once the data has arrived here, that's where you store, or even for that matter, manage the stream for real-time analytics, real-time data lookup. Now, data has arrived in the cloud. So what happens here onwards is interesting one, right? Now, if you look at the Azure Digital Twin, there are two building blocks here, right? Under Azure Digital Twin. Number one, it's a twin model and a twin graph, right? So basically, the twin model talks about what is your asset. If you look at a smart building, what does it comprises of, right? So, for example, it might have 20 rooms, 3 floors, etc. So that's basically the model you define. And of course, relationship between various entities in a specific model is defined by the graph, right? So it has a twin model and a twin graph. The best part is, we always said that as Microsoft, we absolutely look at how we can infuse interoperability, openness into everything we offer from a platform perspective. This is a classic example of how for the twin model to be defined, we support something called digital digital twin definition language, DTDL. Again, there are industry ontologies. If you look at smart building, smart factory, there are industry specific schemas available which can be brought right into the digital twin. Yeah, that's one. Number two, we said earlier, yes, I said earlier, yes, data comes into Azure Cloud Service. Now that we've defined the twin model, the twin graph, the data moves from the cloud service onto this particular digital twin. That means data is available for lookup. Yeah. So of course, there are two types of data: incoming stream data, and eventually what to do with the stream is something is left to you. But data is ready to be consumed right now as we speak. Okay. Now this is where it gets interesting. Now the data is here. Using digital twin query language, you can query the data using a SQL-like syntax, right? That means this is where it gets interesting. Let's look at that. Eventually, the data has to be shown in the context of the physical environment, which is a smart building, a smart factory here. It has to come into a GUI representation. It can be a twin, it can be a 2D model or 3D model. That's secondary, but eventually looking at overlaying the data coming from the physical world onto a virtual asset, right? So let's assume this to be a 2D model of basically a smart factory. So you're going to overlay data onto the particular 2D model. How do you do that? Basically, you use DTQL, digital twin query language, and you query the digital twin and overlay that on the virtual asset equivalent of physical world. By the way, it's not one directional, it's unidirectional, it's duplex communication. That means you query the twin, you look up the twin graph and display the data on this particular twin, and if you have to apply the data back to the physical environment, that means imagine you have a temperature which says, hey, right now the temperature is 70 degree Fahrenheit. You want to bring it down to 60 degree Fahrenheit. You can send the data back to the physical environment because there is a straight through path available, right? Because data has come from factory floor to the virtual environment, and you can send the data back to the factory floor so that you can apply and action that particular event which is supposed to happen on the physical environment. Yeah. So on the whole, this is a classic representation of what is the design behind a digital twin. This visual is a classic representation of that, right? From the factory floor, data moving from factory floor onto Azure Cloud Service, which will be manifested within a digital twin, and you query that using digital twin query language, overlay that on the virtual replica, and eventually if you were to act upon, simulate, etc., you do in the virtual environment. Once you're happy with, hey, I will take this action, send the command back to the factory using digital twin again via cloud service, and the action is applied back to the physical environment. Yeah. So with that, we'll move on and double click how did AB InBev went about implementing that particular solution when it comes to the factory operations, right? We said yes, you need to replicate the physical world in the virtual environment. I think this is they took a 2D approach here. Some of it is 3D modeling, right? They took a visualization approach to make it real for people who are actually monitoring it, right? So if you look at it, Azure IoT, yes, that's something which you infuse into your physical environment. Now, if you look at Azure IoT, yes, we're talking about connected systems. You use Azure IoT Hub to basically establish the communication between the physical environment and the public cloud, and you can monitor, manage the assets. Again, as I said, it's a duplex communication. You look at the safety, security of the device also in addition to communication. Now, of course, the use of computer vision becomes so critical across the board in terms of managing the spaces. So Azure Percept comes in terms of computer vision speech models, which are out of the box. Now, one of the important questions customers ask for a long time is, hey, how do we secure this IoT sensors and devices, right? Of course, industry dominantly follows the OPC UA pattern in terms of it's a unified architecture, open protocol communication, unified architecture. Now, if you look at any asset within a physical environment, not everything would have cloud connectivity. You go through OPC UA gateway as an example. Now, how do we secure the assets and the gateway? That's where Azure Defender for IoT comes in. That's something which is part of our overall security suite under the umbrella of Microsoft Cloud. Now, moving forward, yes, once you've wired up your IoT assets with the cloud services, and this is where the twin graph, the twin model gets defined, which is what we spoke a little while back. And one that is defined, of course, the DTDL, digital twin defined language, what you use, and digital twin query language used to pull data from the particular physical asset. Now, if you observe the video carefully, you could actually navigate through that particular virtual asset as if it's a physical environment. So the spatial mapping, the Azure Maps is used here in terms of getting that particular movement. For example, if you want to understand where the asset is in a real estate, right, and if there is an IoT sensor tracking that particular whereabout, you can actually show in terms of that particular physical layout where it exists, right. It's practically possible in Azure Maps. And once you got the data, of course, there's a hot path and a cold path, right. The hot path data, once you're pulling information from the asset, which is Azure Cloud Service, and showing it on a digital twin. Now, there is also time series data which you eventually update back to the physical environment, right. Now, you have a time series data which you actually store for futuristic assessment. So now, all the data that you have stored for future reference, you can use that for descriptive statistics and even in fact predictive modeling, right. That's where Synapse Analytics comes in handy. And eventually, when it comes to simulation, we mentioned about autonomous systems. Project Bonsai is a classic solution on Azure which helps you simulate some of I would say optimization problems in the manufacturing industry, specific control systems. You can use Bonsai to simulate those scenarios and look at how you can optimize operation by helping a plant manager look at these output from Bonsai to best calibrate, best act upon those control systems. Okay. So from there on, if you look at data as common, you're applying that on a virtual replica, but of course, you also want to bring in automation. You also want to bring in a facade where it's interactive, right. That's where the Power Platform, which is the low code, no code, comes in handy. For visualization, you use Power BI, but a lot of automation, you can use Power Automate. And also, if you're looking at, hey, I need to bring in interactivity via, let's say, a chatbot, you can use Power Virtual Agent to bring in that conversation capabilities, right. Now, once you do that, I think one of the classic manifestation of everything we see in the current times in terms of an experience is powered by 3D experience. That's where immersive experience comes to perspective. Immersive experience comes in handy, powered by HoloLens and mixed reality and metaverse, right. That's the eventual path all of us are on in terms of an experience. And of course, the bulk of the heavy lifting is done by Azure Digital Twin. The visualization is a classic pull-up of information using Azure Digital Twin query language and mash it up on a 2D or 3D immersive spaces. Okay. So yes, we're moving towards industrial metaverse, and that's something which is eventually down the line. But for now, we're looking at how do we bring those experience to life by using the power of Azure Digital Twin. Of course, it's a classic manifestation of data coming from physical spaces, powered by Azure IoT Hub, eventually to digital twin and overlaid on a virtual replica of the physical world. Let's look at this. Now, this everything we've spoken so far, right from the physical environment till visualization, is a classic coming together of a metaverse capabilities on Azure. And we saw earlier in terms of what those capabilities are. But otherwise, as I said earlier, one of the shifts we're seeing in the industry is to move towards industrial metaverse. Especially Microsoft's point of view is to empower businesses here in the context leveraging the power of these technologies. And I said earlier also, my personal belief is there are two trails when it comes to metaverse. There is a B2B and a B2C. In my opinion, the biggest beneficiaries will be B2B to start with, right. So that's where industrial metaverse comes in handy. One of the classic use cases that our CEO Satya spoke about in Build Conference is about Kawasaki. Eventually, we spoke about so far visualization, analysis, predictive capabilities, but can I take that into a shared virtual 3D space? Absolutely. That's where Microsoft Mesh comes in handy. This is a classic example I want to kind of showcase here in terms of how Kawasaki Heavy Industries is looking at everything we've spoken so far, and to top it up, it's going to be metaverse experience. So let's look at that and move forward.
日本では我々ロボットを開発する人間にとってやはり子供のように親である我々開発者がちょっとしたその動きのおかしさにどれだけ気づくかってことは極めて大事な形。ロボットは実は止めちゃいけないんですね。ロボットはずっと働き続けないといけない。そういう使命を持ってますね。
現場でトラブルが発生した時ですね、生産が止まってしまうという、そういったシステムの検討というものが非常に大変です。
Azureコンセプトを活用して、今まで気づかなかったような故障であったり、トラブルっていったものや予兆っていったものに気づけると考えております。 遠隔地の方にエキスパートの方がいてくれるだけで、一つの作業現場に技術力であったり知見っていったものを流すだけではなくて、複数の作業場っていったところに提供しまして、そうすることによって即時にトラブルシュートを迅速化できます。
それが、デジタルツインの世界ができますと、実際現場に行かなくてもそのトラブルの状態が手に取るように分かって、そこでもう直すことができると。そういったものがですね、仮想空間の中で全部調べれるようになります。
完全なるメタバースの世界は、開発から設計ないしは試験までの全ての工程っていうものを仮想環境上で実行できます。
マイクロソフトさんとインダストリアルメタバースの世界をぜひ一緒に実現していきたいと考えています。
Wow. Were they working in the metaverse? Absolutely. I think future is where you, irrespective of location, you'll be able to manage the show, and this is one classic example. Of course, very real in terms of how they could do predictive maintenance via remote monitoring on an asset and predict failure and accordingly act upon resolutions as they go along. Yeah. So we'll move forward. Now let's look at. We spoke about Azure Digital Twin, but there are 4 key tenets powering this Azure Digital Twin as a technology. Let's look at those things. The first one, of course, open modeling language. I mentioned earlier about digital twin definitive language. We support industry ontologies. We look at how that is. Second, of course, live execution environment. For us to literally look at data in real time, technology should support that, and that's something which is relevant for us to light up an experience. And number 3, number 4, in terms of how do we kind of bridge the physical and the virtual, that's an important aspect as well. And of course, when it comes to output, how can we leverage or harness the power of the massive corpus of data that's created because of TSI, time series insights, is something we look at it as well. Yeah. So first things first, I said open modeling language. Yes, we talk about supporting industry ontologies in terms of digital twin definition language. That becomes easier for anybody to construct a virtual replica of the physical environment, and that's something which is part and parcel of how you actually look at lighting up a digital twin in Azure and try to bring in your twin model and a twin graph to build a relationship between the physical and the virtual world. Yeah, this is something which is, again, as I said, it's a JSON file. You construct there and upload it to the twin graph, and Twin Explorer will actually help you explore that in a very, very easy fashion using a SQL-like language there. Live execution environment. Now, once you've created the digital twin and you have the graph and the model set up, now this is where the surrounding technologies come in handy, right? For example, when data comes in, what should be done? Or when before data is sent to, let's say, digital twin, is there need for us to transform the data? So all those decisions you take using the power of, let's say, Azure Functions, the logic apps, right, in terms of BPM and those aspects come in handy. And that's the power of the surrounding tech around Azure Digital Twin. Inputs from IoT and business systems, yes, when it comes to, I said earlier, it's a duplicate communication between the physical and the virtual world. Now, this is where Azure IoT Hub comes in handy, right? End of the day, you have an asset in the real world, you're tracking that, tracing in terms of how things are happening, but end of the day, you also need to manage the device in terms of its heartbeat, whether it's working or not. Number 2, apply updates on a regular basis to make it secure. Also look at securing the device using technology. So that's where the inputs from IoT and business systems come in handy to make it real when it comes to digital twins. Number 4, in my view, it's the most it's important element across the board. While everything is important, this becomes essential because you're looking at a virtual replica where you can simulate things, you can predict for the future, and it eventually lead towards prescription, right? That's where capturing output to time series insights become very critical. That's a classic representation of how you look at advanced analytics, leveraging the power of digital twin and simulation, autonomy, and eventually predicting for the future. Now, I mentioned earlier, by the way, I have a wonderful demo to showcase in terms of some of the capabilities that we've spoken so far, and look at amplifying experiences in 2D and 3D spaces, right? Of course, we're talking about 2D view. By the way, there's also a cool announcement that happened at Build Conference called 3D Scene Studio. So that's something to help us bring in a perspective view in Azure Digital Twin in terms of looking at a replica of the physical world in the virtual environment. So we'll look at that as a demo later. But right now, one of the experiences we saw earlier in terms of a facade on top of all the metaverse capabilities is Microsoft mixed reality and a digital twin, right? So what you're seeing right now is a classic representation of a windmill farm where you're looking at real-time data coming in from the assets within the physical environment. Now, every windmill has IoT sensors that's sending data to the Azure cloud services. Now, how you're taking that data and matching it up as a 3D view, right? That's something which you're seeing right now. Of course, it's dual-play communication, I said earlier. So you might get an alert very soon saying some windmill has gone wrong. You can choose a specific windmill and look at that particular windmill and see what has happened, what has gone wrong with the data. For example, rotor speed is basically turned red. Now you want to send a reset command, absolutely possible. So that becomes a dual-play communication, right? That means you're going to use digital twin query language and look at the data and send the data back to the physical environment by updating via an event there. Yeah, this is a classic representation of how mixed reality, digital twin come together to offer that immersive experiences for anybody for that matter. Now, I mentioned about 3D Scene Studio. This is a visual of that, and we'll probably get into demo right away to first of all show you how do you construct a digital twin, how do you look up data and display it or overlay on the digital twin representation in the virtual environment, and of course, how do you take that data and manifest that on a 3D scene for the experience to be a lot more immersive, a lot more relatable, because end of the day, if I can get a replica or a model of a physical environment in the virtual world, it's a lot more relatable and there's a sense of belonging, and of course, it's more context to it. Yeah. So we'll look at the demo and we'll move forward. All right. As you see on the screen right now, I'm in the Azure portal. There will be two parts of the demonstration. First part, I'm going to take you through Azure Digital Twin, which I've just created for sample purpose. And I'm going to take you through how Twin Explorer helps us look at a digital twin model and the graph associated to pull up information. So we're going to see that first. And second, of course, we'll explore how easy it is to basically bring in a 3D visualization on the digital twin, right? So let's get right in, and I'm going to choose the digital twin I've just created. It's a temporary instance, and by the way, I already uploaded the twin graph and the twin model. We'll show that to you quickly. We'll just open Twin Explorer. It's in preview right now, but when it loads up, I'll take you through what information we get out of the box as it loads so quickly. Now, by the way, I've already uploaded model, I said, so let's look at the floor and the room information. This is about a building. Building has floors and rooms, so I've just uploaded that. Let's look at the model. This is the JSON, as you see here, right? The display name is floor, and the relationship it contains basically rooms, right? And if you look at the rooms, if you look at the model, it talks about, yes, the display name is room, and it also has two properties, temperature and humidity, right? This is what it represents when it comes to information. For example, the information you pull from the physical sensor, you upload that through Azure services onto Twin, and these are the two properties holds information which comes in real time. Yeah. Now on the top you see SQL-like query, select star from digital twins. Let's see what happens when you run it. So what you should see is visual representation of course, floor 0 has room 0 and floor 1 has room 1. Yeah. So of course I can actually go ahead and look at what information it contains. It's a JSON floor 1, and if I click on room 1, it talks about, yes, there is temperature, etc. Now let's look at how do we query. So as I mentioned earlier, you use digital twin query language to pull information. Let's say the second query, right, where I'm pulling information which I have to overlay on my visualization, right? This is where it gets interesting. So you can query, filter basis what you want to display. And let's look at this and run the query. Let's see what comes up, right? This is an example of basically how you'll be able to proactively seek information. Now, I mentioned I need information of rooms where temperature is greater than 75. It gave me room 1. And it's also two-way communication. Earlier I said that it's not a one-way traffic, right? It's a two-way communication. That means I should be able to send information back to the physical world by way of conveying what should be the temperature at any given point in time. And I'll be able to do that just by digital twin query language, right? That means I want to update back the twin with information where it can go back and update the physical environment. Yeah. So this is first part of the demo. And switching to the second demo, recently I had the opportunity to talk to one of my colleagues, Shailendra Miglani, who is IoT expert at Microsoft, and basically he took me through how easy it is to build a 3D visualization on top of Azure Digital Twin. Let's jump into that video and we'll come back.
So we did announce 3D Scene Studio around the build time frame.
Yeah.
It actually offers you a 3D immersive environment.
Right.
So what happens is you have your IoT data, which is coming in real time, right?
Right.
So essentially, when the data comes in real time, when you are using Azure Digital Twins,
Right.
you're trying to create a live execution environment
Right.
in Azure Digital Twin in a
Right.
kind of a graph.
Right.
So once you have the data, right, the next step would be how do you visualize it in a kind of a 3D viewer, right? So we previously we were using third-party 3D viewers,
Correct.
wherein we required certain platform components,
Right.
and we required it to manually connect it. Plus, it was not that straightforward, right? It required a bit of a manual connection to connect it to 3D viewers.
Right.
But now with 3D Scene Studio,
Yeah.
we can natively essentially create a live, a 3D immersive experience,
Right.
wherein you can look at the incoming IoT data and visualize it and augment it on a 3D model.
Actually, in fact, one of the biggest challenges, how do we visualize things in 3D space? So customers use different, I would say, 3D model software. So can I bring any format into 3D Scene Studio?
So that's a good question. So in fact, to get started with 3D Scene Studio, we
Yeah.
essentially require GLB or GLTF format.
Okay.
So, so if let us say if the customers are using models which are in different format, there are industry business tools, there are industry standard tools which are
Right,
available,
right.
by which we can convert into GLB or GLTF format and then get started.
Okay.
So get started with this. Essentially, what you need is a 3D model, ADT, and a storage container to just get started.
Awesome. So Shailendra, I think this is great. I think it's time to take a quick look at the demo because I'm curious to see how easy or difficult that would be. So let's jump right into the demo.
Sure. Thank you, Sandeep. So Sandeep, as you can see, this is a Azure Digital Twin,
Yeah.
right? Where I have a distribution center, where I have multiple robotic arms. This is a mock setup where I
Right.
have simulated the data. So the data which is coming onto Azure Digital Twin, and I go to the next screen, which is essentially my 3D screen.
Got it.
Here I have taken a GLB file and for this, and I have uploaded it. And as you can see, I have 6 robotic arms which are running.
Right.
So in this case, there are again 2 views. One is a build view, and other is a consume, which is a visualization view.
Yeah.
So in the build view, you can in fact create behaviors. Behaviors are nothing but these are visual rules. So in this case, for example, I have a camera
Okay.
where the camera is looking at these robotic arms. The robotic arms are picking up boxes
Okay.
from one place and dropping at the other. In case a robotic arm misses a box, then I issue a alert. Right?
Perfect.
So in case so I record it as an event.
Okay.
And if the event, for example, if I have more than these 3 events, I can issue an alert.
Oh,
So I have all these configurations I have done in the behavior
Got it.
already.
Nice.
And I have attached this behavior to assets, which is arm 1 and arm 2 at this point of time. And I
Perfect.
can do similarly for other arms.
Sure. Sure.
So then I go to my consume layer. So in this case, I can also, what I have done is I have created these widgets, which is possible in this 3D view. So as you can see, there is a hydraulic pressure, which I am able to show in arm 2.
Okay.
And there is a live arm camera, which I can show again
Okay.
using open link. So in this case, as you can see, right, so these are like a 3D, this is again a 3D
Beautiful.
view, which essentially is showing you all the different arms. And I can, in fact, click on any one of them and look at the live telemetry. For example,
Okay.
in this case, this is arm 2, then I can go to the arm 1, and I can look at what the hydraulic pressure and the light speed
Brilliant.
is, right?
Brilliant.
And this is getting updated with Azure Digital Twin in real time. So it is very simple, and we can get it ready in minutes.
Awesome. So what you just saw was a classic demo of how do you actually construct a digital twin from scratch, and of course, how do you take that into a 3D environment to look at a perspective view of your operation in real time. So yes, we live in a time where we're moving from connected systems right now into a predictive environment and eventually prescriptive environment, right? So that's the horizon we're seeing in terms of innovation in industry. As Microsoft, yes, there is a ton of innovations underway to make it reality. Of course, eventual classic manifestation, everything we've spoken so far is industrial metaverse, and that's not too far. And hopefully, with new innovations coming around the corner, we see that in reality. With that, thank you so much for joining me today, and have a wonderful summit ahead. Bye-bye.